So let's move further. In the last video we talked of adsorption. We have drawn a structure like this. The molecules or atoms present here try to adhere the foreign molecules. They may be gas, these are solid, and the foreign molecules may be gas or liquid. These foreign molecules make a layer of them on this surface only. The bulk of the material here, in the bulk, the concentration of these foreign materials is approximately 0. That means these foreign particles remain only at this surface and form a layer over there in the process of adsorption. There is a second process which is known as absorption. I hope you know that. Let's try to discuss that now. See, in absorption, first one was AD, now it is AB, absorption. See, this is the process in which some foreign particle uniformly distribute. This is foreign particle, this uniformly distribute over this surface as well as in the bulk. See how this happens. First it was adsorption. In that case, in this adsorption, this foreign particle just adheres to this surface and form a layer over there. So the concentration of this foreign particle is maximum at this surface, because the driving force which is responsible for this adsorption is just this material, in which the force of attraction due to the bottom particle is to be balanced by this. That's why this foreign particle just remains here. Now this absorption, what happens in this absorption? It is basically the driving force in this absorption is the concentration gradient. Concentration, CONC stands for concentration, and this is gradient. When any foreign particle, this is not a solid, it is liquid. Now for example, this is liquid and some foreign particles may be gas which comes in contact with this. These foreign particles uniformly distribute over the surface as well as in the bulk. Let me discuss it more clearly. Let's take an example of absorption column. In this absorption column, gas, for example ammonia, NH3, is sent from the bottom, and liquid, that is water, is sent from the top. This is water and this is gas going up. During this process, these two phases, this is liquid phase and this is gas phase, these come in contact here, and the gas NH3 gets absorbed in this water, because the concentration of ammonia in water was 0 and the concentration of ammonia in itself obviously was 100%. That is why this ammonia will flow from higher concentration to the lower concentration in water. That is why this ammonia gets absorbed in water, and the driving force for this process, this absorption process, is the concentration gradient. That means there is a difference of concentration of this molecule. Now let's talk of these in a bit detail. In adsorption, AD adsorption, we saw two things. First, the surface on which the adsorption takes place and the foreign entities which are adsorbed on this surface. This surface on which adsorption is taking place is known as adsorbent, and this foreign entity which is being adsorbed on this surface is known as adsorbate. The common examples of this adsorption are, I hope you may have seen the whiteboards. When we write something with marker on this and left it for quite a time, this ink gets adsorbed and it is very difficult to remove over there after some time. This process is generally an adsorption process. These liquid particles, these foreign entities are now liquid present in ink, and this surface, this was our white board. This process is an example of adsorption. Let's give an example of absorption now. Absorption, you may have seen many examples in day-to-day life. Let's take a piece of cloth and put it in some bucket of water. This water will get absorbed in this piece of cloth on the surface as well as in the bulk of this cloth. This is the general example of absorption. I hope this is clear to all of you now. Now let's see what happens to this adsorption when we change temperature. See, there is a equation called Gibbs-Helmholtz equation. It's like this: delta G equal to delta H minus T delta S. This delta G is change in Gibbs free energy. I hope you know this from your 11th level. And this delta H is change in enthalpy. This T is here absolute temperature. Absolute temperature means temperature in Kelvin scale, absolute T. And this delta S is change in entropy. Let's see how this governs our adsorption now. It was like this: delta G equal to delta H minus T delta S. Now this delta G, it's the Gibbs free energy, as the Gibbs-Helmholtz equation suggests that for any process to be feasible, this delta G should be negative. Delta G should be negative. That means Gibbs free energy during any process should decrease. What do I mean by that? If a state of system is basically at this, and after some process, by some changes, we took it to some another state. For example, here temperature was T1, pressure was P1, and now temperature is T2, pressure is P2. During this process, here its Gibbs free energy was G1, here it was G2. This G1, this G2, this G1 should be greater than this G2, because delta G is G2